I can write linear equations in normal form and write the standard form of the linear equation given the length of the normal and the angle it makes with the x-axis. A normal line. A normal line is a line that is perpendicular to another line, curve, or surface and passes through the origin. The angle between the normal line and the x-axis is phi, the Greek letter phi. In our picture here, we are trying to point out that this line here is our normal line. The angle between the normal line and the x-axis is phi. This ordered pair, where the normal line intersects our line, if we think about the unit circle, cosine theta sine theta would be our unit circle. And when it's not a unit circle, we have to times it by the length of the radius. So if we had a circle around here like this, then this would be my radius. And so that's why we have P times cosine of our angle phi represents the x-coordinate, and P times sine angle phi is our y-coordinate right here. Normal form of a linear equation is x times cosine phi plus y times cosine phi minus p equals 0. That is the normal form. So when they ask for an equation to be in normal form, we want it to be in this form right here, where p is the length of the normal from the line to the origin. You see I have a typo. This is from the line to the origin. And phi is the positive angle formed by the positive x-axis and the normal. Changing the standard form to normal form. The standard form of a linear equation, ax plus by plus c equals 0, can be changed to the normal form by dividing each term by a plus or minus square root of a squared plus b squared. The sign is chosen opposite the sign of c. So we won't use plus and minus in this situation. We will choose it's either going to be a positive number or a negative number determined by the opposite of the sign of c. Okay? And right here is c. So example, number 16 from your book. The directions for number 16 ask us to write the equation of the normal in standard form. And so the model we use would be x times cosine phi plus y times sine phi minus p equals 0. If we substitute in what we have, we get x times cosine pi over 2 plus y times sine of pi over 2 minus 2 equals 0. And so now we have to use our knowledge of the unit circle and say, what is the cosine of pi over 2? And the answer is 0. What is the sine of pi over 2? The answer is 1. And so when we simplify, this cancels, and I get y minus 2 equals 0. And that's in standard form. So on number 22, the directions say write the equation in normal form and then find the length of the normal and the angle it makes with the positive x-axis. And so first thing we want to do is change this equation into standard form. X plus y minus 1 equals 0. So we have ax plus by equals, ax plus by plus c equals 0. Now we're in standard form. And so we want to find plus or minus square root of a squared plus b squared. And so that is square root a, which is 1, plus b, which is 1. Okay? And then the sign we choose, remember, needs to be opposite the sign of c. So it's going to be a positive. And 1 squared plus 1 squared is 2. And so we get the square root of 2. And so we divide every term by square root 2. And so that's x over square root 2 plus y over square root 2 minus 1 over square root 2 equals 0 over square root 2. And as you know, it doesn't matter to show 0 divided by square root 2. That's still going to be 0, isn't it? Okay. So then, what we do is we rationalize this and we get square root of 2x over 2 plus square root of 2y over 2 minus square root of 2 over 2 equals 0. And so how long is our normal? Well, our normal is p, which is this number. Now this is a negative, but we're asking for the length. And so we're really thinking of this as the absolute value of p. They don't write it that way, but it's understood we're looking for a length. And so p is really just the square root of 2 over 2. And so now we have to find theta. Remember, this number represents, find phi. This number represents the cosine of phi. And this number represents the sine of phi. And it's important that we recognize the signs. This is a positive, and this is a positive. And so that means then that we are in quadrant 1. And so when is the cosine equals square root of 2 over 2? That is when phi is 45 degrees. And when is the sine equal to square root of 2 over 2? Also when phi is equal to 45 degrees. Now you don't have to do both of these. We only need to find the value of phi once. But it is important that we notice the signs and make sure we're in the right quadrant to get the angle we want. Since they're both positive, we're in quadrant 1. So remember, our assignment today is lesson 7-6, 13 to 31 odds. You need to do as many of these as you can. And if you need help, Mr. J will be able to help you. And in my green folder. Mr. J can find all the problems worked out. If there's one that gives you guys extra trouble, you can look at mine, but please, Mr. J, do not allow them to take my papers out of my notebook and lose them. Good luck. See you on Monday.